Hi, hello guys. This is yet again another time that we've met on this live stream. I want to welcome you to this session where we'll be discussing matters that are related to orthographic projection. So therefore, welcome and let us begin. This is Waithaka Simon for the Technical Training Channel. I want to welcome you. I want you to engage me on my comment section in case you have any question, in case you have any comments to make. This is a channel that deals with educational content and basically on the building section, civil engineering, architecture, quantity surveying, and we deal with, we generate content that is related to technical drawing, engineering drawing, history of architecture, structures, surveying, drafting software. So we deal with quite range of educational content, and that's why I wish to invite you to this channel, be with me for this session. If you are not a subscriber, kindly subscribe to support us in order to be able to generate more content, to be able to assist more trainees in their educational journey, and even be able to achieve their goals at the end of their session for whatever courses they are undertaking. So for this session, we'll be tackling matters that are related to orthographic projection. Therefore, I want to welcome you, engage me as I had said earlier, through comments on the comment section, so that we, in case of any question, in case of any clarifications, we'll be able to address them. Therefore, welcome and let us begin. So I'm just sharing my screen with you so that we are able to follow on the presentation. So kindly let me share. There we are. I'll be using the graphics card to demonstrate concepts in orthographic projection. So I believe that we'll be able to follow up. We'll be able to get the concepts as they are supposed to be delivered. Therefore, let's continue. In case, as I have said earlier, if you have a question, just engage me on the comment section. I'll be able to respond as we move on. You can also let me know if you are getting me clearly. Just let me know through the comment section. So this is the page where we will discuss concepts that are related to orthographic projection, and therefore when we talk of orthographic projection, we are basically talking of projection of objects in angles of 90 degrees, because basically orthographic or ortho means 90, and therefore projection, you are basically talking of, you are given an object of this nature, maybe a cuboid, maybe a cube, or a rectangular block, and then you are required to project the views in either first angle or third angle projection. So when we talk of orthographic projection, we only talk of two angles, that is first angle projection and third angle projection. First angle projection and third angle projection. So therefore, we will start with the concept, and we see how views in first angle projections are usually organized. And therefore we will basically discuss this simple block, and we see how the views are projected when we talk of the front view from A, uh, then side view from B, and of course plan from above. So we are saying we'll discuss a front view from A, end view from B, and then plan from which is a top view. And therefore, when we talk of the front view, we'll basically be talking of this view. That is the view that we'll be looking at. We'll be looking at in as our front view. Then the plan is always from the top. So the side that I've highlighted with green will be our front view, and then the plan is usually from above. So anytime when we talk of plan, is a view that is generated when you observe from above, or what usually known as from bird's eye view. Then we also have the end view, the one I'll highlight in blue. So whatever is we are seeing in red is our plan. Whatever we are seeing in green is the front view, and then whatever we are seeing in blue is what will represent our end view. So therefore, we will generally discuss this block and see how we can project it in first angle, because what changes again now is the nature of the object that will be required to project going forward. For now, we will use a simple rectangular block, and then we will pick an example of a different block and see how we can project it in first angle. So therefore, in first angle, or in orthographic projection, we said we are projecting views in 90 degrees, or using angles of 90 degrees, and therefore that's why we usually have a Cartesian plane that has four quadrants, and these four quadrants will give us the different views of the block that you are supposed to project. And therefore, in first angle projection, the front view or the front view is usually placed with respect to the end view. Therefore, if for this case we are required to project side A, B, and C and plan, where A is the front view and B is the end view. Therefore, in first angle projection, the end view that is to the left of the front view is usually projected to the right. The end view that is to the left, as you observe the block, whatever you are projecting, if the end view that you are required to project is towards your left hand side, then when you are projecting it, we project it to the right hand side of the front view. When assuming that we are also supposed to project a view and a side view from just a minute, I put another arrow. If we were supposed to project another end view from D, or the opposite of B, if you are to project an end view from D, therefore basically it means that the end view from D, the end view from this side is basically to the right hand side of our view, and therefore in first angle projection we will project it to the left. I think we'll be able to see the difference once we project, because we'll be able to see how B and D alternates within the Cartesian plane when we are generating the views. So therefore, since we are supposed to project A, B, and the plan, therefore our end view, because it's on our left-hand side, will go to the left. Will go to the right. Sorry, our end view, because it's on our left, will go to the right, and that means that our end view will be placed on this of the Cartesian, because this is our right hand quadrant of the Cartesian plane. We've said the plan, the end view goes to the right, because this one, the one we are supposed to project, is to our left, so we project it to the right. So therefore, we will begin by projecting the front view. The face that we are seeing in green is the one that we project, and that face is the one that we project in this quadrant. So that end view now will be projected to the right hand side of the front view. And then, of course, now the plan is always usually below the front view. Plan is usually below the front view. So therefore, in first angle projection, at this point we'll have our front view. We'll have our front view there. Then we'll have our side view here, that is coming from the left hand side. So we'll have our front view at this point, and then we have our left end view towards the right of front view. And then below the front view, we will have the plan. We'll place our plan. We'll place our plan there. And maybe now, because before we proceed and start projecting, just allow me to get feedback from the comment section and see whether we are moving together before we continue. So kindly let me know from the comment section. I can see Sami is saying is getting me clearly. So maybe the others who are on board, maybe you can still let me know whether we are moving on together. For now, I'll just proceed with the presentation. But in case of anything, just comment and I'll be able to respond. So I'm just sharing the screen again so that we move together. So we will proceed and project the given views in first angle, and we'll start with the side A, front view A, and it's basically a rectangle that measures 60 millimeters. It has a length of 60 millimeters by 40 millimeters. It has a length of 60 millimeters by 40 millimeters. So that is what we will project as our front view at this place under whatever we had labeled earlier as the front view. So therefore, I'll just use another type of line so that we are able to follow. So for us now to project front view from direction A, we already have our Cartesian plane, whatever is in red, and maybe I can adjust the colors for the construction line so that we are able to follow up. So whatever now is in green is our construction lines and denotes where our views will begin, where our views will begin. Therefore, our front view will begin from this point, and from this point we will measure a distance of 60 millimeters towards the left, and that will give us the length. That will give us the length of the front view. So I'll just drag this line, a distance equivalent to 60. To 60, and that will give us the length of our front view, the length of our front view. And then we need now to define the height. And from our object, we can see that the height is 40 millimeters. So therefore, from this line, I will draw a line at 40 millimeters. At 40 millimeters. And then this now will give me the front view, which is a rectangular face of 60 millimeters by 40. So we'll have our front view there, 60 millimeters by 40. Maybe I can just highlight it in black so that we are able to see. So that you're able to see what we are talking about as our front view. So that will be our front view, because it's just a rectangular shape, 60 millimeters by 40. And then you'll note that the length of the front will give us the length of the plan, because we said that plan is what will come directly below the front view. So plan will be just directly below the front view, and therefore we've already defined the length of the plan. The length of the plan, which is the figure, which is the face that we had highlighted red earlier on, which has a length of 60 millimeters by 30. 60 millimeters by 30. Therefore, since we already have the length of the plan, then we will define the width of the plan, which you've seen is 30 millimeters. Then starting from the construction line where our view begins, then I'll draw another line at 30 millimeters. At 30 millimeters, and that will give me now the plan view. It give me the plan view. Maybe again I can highlight it in black. And that will be our plan. So we have a front view there, we have our plan directly below it. And then now for us to generate the end view, remember we said that our end view in first angle projection will always be opposite the front view. And for this case, we said because we were required to generate end view from our left hand side, in first angle projection it will be positioned to the right hand side of the front view. Therefore, it will be placed at this position where we had indicated earlier our left end view. So therefore, for us to be able to do that, we will draw a reflector line from the center of the Cartesian plane at an angle of 45, and that is the reflector that will assist us to generate the end view. So therefore, I will just draw a reflector line at an angle of 45. I just use red again from the center of the Cartesian plane at an angle of 45. At an angle of 45, sorry, just use a straight line that has no joints. At an angle of 45. So this line gives us, will help us to generate the end view at this point. And what happens is that you'll find that the details that are coming from the plan will be, at some point, they will be cut by the reflector line. They will interact with the reflector line at some point. And we can see from the first line where we started generating our front view, it meets with the reflector line at that point, and we already have a line that we had done before as a construction line for the end view. Therefore, the other line that is defining the width of the plan will interact at the reflector at some point, and at that point, that's where we will draw another vertical line, so that it will help us to generate the end view at this particular point. And for this, because this is just a simple rectangular block, our end view is a rectangle measuring a width of 30 millimeters and a height of 40 millimeters. So from the front view, we are able to get the height of the end view, and from the plan, we are able to get the width, because what we've transferred to the reflector line is just the width, and we've transposed it or projected it up to get the end view. And therefore, just again highlight it in black so that we are able to see the end view just a little bit. We are able to get the end view and visualize how it's supposed to be projected. So I've drawn it in, maybe I need to change that to black for uniformity. So, and that will now give us a first angle projection of the rectangular block. So maybe as an overview of what you've said in first angle projection is that when we are projecting views in first angle projection, the left end view will always be projected to the right hand side of the front view, and the right end view will always be projected to the left of the front view. And then, of course, the plan now will be projected below the front view. It's important to understand how the left and right end view behaves in first angle projection, because when we move to that angle projection, we will see a difference in how the views are organized in terms of the left end view and the right end view, and even the plan. But for now, what we need to understand in first angle projection is that when we are required to project an end view that is on our left hand side, we will always project it to the right hand side of the front view. When we are required to generate or to project an end view from our right hand side as we observe the block, then definitely that end view in our Cartesian plane is always projected to the left. So that is the concept behind first angle projection. And maybe before we move to that angle projection and see the difference, I think it's important again. I check on your comments in the comment section so that we move together. So I can see Hashan is asking why we are not using the right end view or is the same with the left end view. We are not using the right end view because the question required us the question the requirement was to project end view from the left end view, that is from B. So the D part, I just brought it to show the difference and to show how the views behave when you are required to generate from either B or D. So in most cases, in orthographic projection, we'll always be required to project three views: the front view, end view, and the plan. And therefore, when you are given the front view, will always be front view. What changes in first angle projection is the end view. So if you are required to project end view from the left hand side, then in your Cartesian plane, it goes to the right hand side and vice versa. So that is why that's the difference, and that's what makes first angle to be first angle. But for this case, we were required to use B as our end view, and that's why we've used B. So I think the rest are following. I think the rest are following. I can't see any other question, but I think now we can move to that angle projection. I think we can move to that angle projection so that we are able to see the difference between the two, the first angle and the third angle projection. So therefore, allow me to share my screen again so that we move to that angle projection. So just a minute, I'm sharing the screen. So when we come to that angle projection, again, we will pick just the same example of the same rectangular block and see what changes now between first angle and third angle projection. So again, I'll just use the same colors that we had picked earlier on. So that we are able to relate with the same block and see what changes when we come to third angle projection. So the difference between first angle and third angle projection is that in third angle projection, the left end view will always be projected to the left. It does not change. End view, if you are required to project end view that is towards the left hand side from the block that you've been given, then that end view remains to the left. The right end view also remains to the right hand side of the front view. So in that angle, the left end view and the right end view do not change. They remain in their position in relation to the front view. So for this case, we are required also to project B. We are also requested to project front view from A, side view from B, and the plan. because we said plan will always be plan, whether it's indicated or not. When we are told it's plan, we know it's a view from above. So therefore, because end view in our end view in this scenario is towards our left hand side of our view, then it will remain to the left. And then the plan in that angle projection is usually projected above the front view. So in first angle, we said end view from the left goes to the right hand side of the front view. End view from the right in first angle goes to the left front of the front view. And therefore, the plan in first angle projection is usually projected below the front view. So therefore, in that angle, we've said, we've demonstrated and said that in that angle, the end view from the left will always remain to the left of the front view. And the left view from the right hand side will always be projected to the right hand side of the front view. And the plan in that angle projection is projected above the front view. So therefore, let us do project the views and see how they will appear as compared to first angle projection. So therefore, again, my construction line, I will turn them to green so that we are able to follow. We use the same Cartesian plane as we used in first angle, but then now the views will change a little bit. So our plan in relation to the end view will be our front view in relationship to the end view. We'll place it in this quadrant. Then we'll have our end view in this quadrant, because we've said that the end view does not change. It will remain to the left of the front view. So we have our front view here, we have our end view here, and then we said the plan is always projected above the front view. So maybe I can just denote that so that we are able to follow. So at this quadrant, we'll have our front view. Our front view there. Then at this point, we'll have our end view. Have our end view there, and then above the front view, we'll have the plan. We'll have the plan. You can just place it where it's supposed to be. So that is how views in that angle projection will always appear. And just as I said in first angle projection, in most cases, we will only be required to project 3 faces or 3 views. That is the front view, one of the end view, and the plan. And for this case, we are required to project end view that is on our left-hand side. And that's why we said it will remain on our left-hand side. So if you are required to project another end view from the opposite of B, then it will come to the right. We'll have our plan where we have our end view, and our end view will be where our front view is, and the plan above the front view. So therefore, once we've been able to understand how views are organized in that angle projection, then again we can project them. Then we have we just project them like we did with the first angle projection. So our front view is 60 millimeters by 40 millimeters. So I'll pick my first construction line and draw another construction line at a distance of 60 millimeters. 60 millimeters. That will define the length of the front view. And then for me to be able to define the height of 40 millimeters, then I will pick that construction line. But when we are using the drawing board, we just draw the lines normally with the T-square and the set squares. But this now we've said the height is 40. So there we are, and we already have our front view. We are highlighted in black so that we are able to see how it comes out. Sorry. That will be our front view. That will be our front view. And then we now project and get the plan. And from the front view, just as we did with first angle projection, we already have the length. And now what we need to define is the width. And the width of the front of the plan, because we say the plan is 60 millimeters by 30 millimeters. So the width is 30. So again, I will draw another construction line with reference from my starting point at 30 millimeters. And then I will have defined my plan. So that becomes the plan. That becomes the plan. And then what remains now is to generate the end view. So again, as we generate the end view, we will still require a reflector line now in this quadrant. In this quadrant, so that we are able to reference it. Sorry, it will be in this quadrant so that we are able to reference the plan with the reflector line and be able to get the front, the end view. So therefore, I'll just do a reflector line at an angle of 45. We just use red so that you're able to follow. That's an angle of 45 degrees. Sorry, I've misplaced my reflector line. So the reflector line should be at the center of the Cartesian plane. That's where you generate your reflector line from. And now we can see that the height, the width of the plan has already been reflected, has been identified by the reflector line. And then at that point, we draw another line to define the width of our end view. Sorry, let me just draw and maintain the one that we had before. So there we are. We are now able to get our end view. Maybe I can just highlight it in black. That becomes now our end view. And we can see it's generated from, it's projected from the plan, and the height comes from the front view. So those are the three views that we are required to project in first angle and third angle. So we did first angle before, but these now are views that are projected in third angle. And you can see, as we said, that the end view from left will always be maintained to the left of the front view, and the plan is done above the front view. So that is that's how the concepts in third angle projections are usually portrayed. And I believe maybe at this point we are able to know the difference between first angle and third angle projection. And therefore, maybe before I also do, we said we'll do an example of a different block so that we see how the views will come out and how we even approach a question of that nature. Let me just pull down my the screen so that I can see whether there are questions or comments that we need to respond to before we look at the example. So again, you can see there are no comments, there are no new comments. So I believe we are moving on well. Everybody is following up. But in case of any question, just post a comment and we'll be able to respond to it. It's also good to note that the same video is being recorded. We still share it on the channel. You can go back and revisit and if there is a concept that has bypassed you or something maybe that I've covered a little bit fast, you can still go back and watch the tutorial and catch up where you have missed one step or two. So therefore, let me share again my screen again so that we look at a sample question where we are required to generate or to project views in either first or third angle. So I'm just sharing my screen so that all of us are on the same page. So I've picked a question in one of the past papers. It's just a simple one, but it will help us to understand maybe the concepts of orthographic projection in a better manner, because we want to use this example to be able to project it and see how we would project it in case is a question in an exam where we are required to project it in either first angle or third angle projection. And therefore, the question I've picked, or the question reads that figure 1 shows a block in isometric. Figure 1 shows a block in isometric. Isometric is whatever is the block that you are given. Because isometric are usually drawing that are generated at angles of 30 degrees. At 30 degrees and of course vertical lines. That will give us an isometric drawing. So the question is that we've been given a figure in isometric, and then now we are required to draw the views of the block in third angle projection. We are supposed to draw the views of the block in third angle projection. The first and foremost thing for us to do is to interpret the figure that we've been given. So it's very important for you to be able to understand and to interpret the figure and see that you are able to know which face represents the front view, represents the plan. What will you see from the end view? It's very important for you to be able to project views in orthographic projection. For our case, we've been told we are supposed to project it in third angle projection. So therefore, we'll go ahead and try to interpret and see how the views will appear in that angle projection. But before that, it's good, as I said, it's important for us to understand you'll So I think there was a technical hitch. I don't know where we left at. Maybe you can just let me know the where we went off at. I had shared my screen. I was not able to see the comments. So kindly let me know if you're back. If you're back, we had some problem with the. I hope maybe it was the net, but we are back. Kindly write a comment and if you are still following. Okay, maybe let me just continue with the few who are there, and then maybe we'll just follow up with the recorded version of the projection. We were saying when now we want to project the end view, the front view, we will project it at this point. The plan will be above here, and the end view will be at this point. Therefore, we start with the front view, and we can see it measures. It has a 10 millimeter and 30 millimeters. That gives us a height of 40. It has a length of 25 and 35. So we'll generate those lines around there. So from this line, we will have our line at 35, and 35 here, because you can see this is 35, and then another one at 25. So at 35, and then another one at 25. 25. Those two lines will give us the length, and then the height. We've seen we have one at 10 and another one at 30. So this one now will give us the one at 30, and we do another line at 10. And then from those lines, now we are able to generate the front view. We are able to generate the front view. So I can just maybe highlight it from that point to that point. Sorry, just a little bit. From that point, that point, that point, that point, that point. And then from this point, we have a slanting line up to that point, and then back, and that now will give us the front view. So the front view, again, as we said, will give us some projections, will give us some details from the plan, and the plan, we said, is what you are seeing in blue. So whatever comes from the front view is projected up to the plan, and now we can define, we've already defined the length of the plan. Now we can define the width of the plan, and we see we have a line at 25 millimeters and another one at 35 millimeters. So we just draw a line. This one will give us one at 35 millimeters, and we have another one at 25 millimeters. 25 millimeters, and then we have another strip here that will give us, of course, that is the one that will also generate the front view. That will also generate will give us the front view. So therefore, we from whatever we've been able to have here, we can see we have another line at 20 that is coming from the plan. So then at this point, we do another line at 20 millimeters, and that will help us to generate the plan. Therefore, we can outline the plan. We will have all that. We'll see that. We will also see that. We'll see the whole of outline for the plan. And then again, we'll have this line and this line. So we have that line up to that point, and then again up to that point. And that will generate us the plan, because we have this face and we have this other face, the one that is slanting. Then from this plan, now we are able to generate the end view, and we just project all the lines that we have that have interacted with the reflector line to be able to generate the end view. So we'll have a line there. We'll also draw another line at that point and to give us the end view. And now from the end view, we said we'll see this part, and we'll also see whatever we saw in plan in blue as part of the end view. So again, we can highlight this. So we'll have that point. We'll also see the whole of the plan, because it's just like a rectangle. And then we'll have that part coming all the way to that point. So that now we have that part, and we have this part that is slanting. So that's how we will the views will appear in that angle projection. And then again, now we have to dimension, because dimensioning is part and parcel of orthographic projection. So we dimension the front view, we dimension the end view, we dimension the plan to be able to complete the task that was ahead. So hope that you've followed up to the end. But for those who are not able to follow up because of the technical hitch, the video will be available on our live section, so that you can follow up from wherever we left at and be able to see how we've projected the block in third angle projection. Therefore, I want to register my sincere appreciation for your perseverance, for staying with this session. And I had planned another session for isometric drawing, but maybe that will come maybe later in the day. But if you still wish, we can cover it even at late at night. You can still let me know, so that we are able to get the concepts as they are required. Therefore, I want to thank you for staying tuned. Kindly revisit the video where you are not able to get the concept clearly, or maybe I rushed a little bit. Again, be also our ambassador. Share our videos with your friends so that they also able to get this knowledge. Subscribe also to support us, and soon we'll also be the channel has content related to different fields in the construction industry, different units or different areas where we are undertaking studies. So therefore, I believe they are of assistance. If there are anything you need us to work on, just comment, leave us comments in our comment section, share our videos, and be our subscriber. Wish to thank you very much, and may God bless you. Thank you.